Hello everybody, Sir Beaton here and welcome back to another mathematics video. In this video we will be looking at a number theory question, a past paper number theory question. So let's head straight into this question. So the question says, the grid below shows three figures in a sequence. Each figure is made up using a small set of squares of unit length that are both colored, shaded, and white, unshaded. So we have figure 1, we have figure 1 here, we have figure 2, and we have figure 3. So the shaded part, it's barely showing because of the copy, but nevertheless we can still see it. So we see the entire top piece here is shaded, and these parts are shaded. And the same thing here, the entire top piece, that would be shaded, and this piece as well. And then we go up one more, and this entire top piece is shaded along with this diagonal here. So it's kind of like a number 7. So as we can see in the different figures, so figure 1 we went up 3, figure 2 we went up 4, and we shaded the entire top and the diagonal. And figure 3 we went up one more, and then we shaded the entire top and the diagonal. So we went up 1, 2, 3, 4, 5. So that means in the other figure, in figure 4, if we have to draw one, we should go up 6 times. And then we shade the entire top, and then we shade the diagonal. So in the space provided below, draw figure 4 in a sequence. I have to go up 1, 2, 3, 4, 5, 6, and then I will shade this entire top here. So we shade this entire top. So let me go back to the other figure. So I say I shaded 1, 2, 3, I shaded 1, 2, 3, 4, and I shaded 1, 2, 3, 4, 5. So it means I will shade 6 again. So 3, then I shade another one, and that'll give me that, and then I shade the entire diagonal. So let's go back to the other figure. So we shade this one here. And that should be my figure 4. So let me just double check. So yes. Now of course I'll draw a nice outline. And that will be my figure 4. And I got my 2 marks here. So let me just double check. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Actually, I should have 1, 2, 3, 4, 5, 6. So yes, I checked all of the boxes, and also 6 at the top. 1, 2, 3, 4, 5, 6. So I checked all of the boxes, and I got my 2 marks. Nice and easy. So let's move on to the next question. So the next question says, the colored squares C, the total number of squares T, and the perimeter of the figure P follow a pattern. Study the patterns in the table below and answer the questions that follow. So complete rows 1, 2, and 3 in the table below. So I have the figure number, which is F, the number of colored squares, which is C. I have the perimeter, which is P. Then I have the total number of squares, which is T. So let's look at what is going on in the table. Let's see to find a pattern. So we have 1, 5, 12, and we have a formula here. And then we have 2, 7, 16, and then another formula. In the next row, we have 3, 9, 20, and then I have a formula. And then I skipped and I got to 11. So you want to be careful. You want to look at these skips. So some persons would think that, the next number would be 4, and you do the pattern for 4. No, they would skip a piece because they want you to think. They want you to find a pattern for all of these here, and then think how to get the pattern for a number that is not following. Let's look at the pattern. Let's try to get a pattern. So let's see how we can move from here to here, because we'll have to get a number for 11 here. So let's see. So we can try 1 times 4 plus 1. That would give me 5. So let's try 2 times 4. That would be 8 plus 1. That would be 9. So 9 is not the sequence. 9 is not in there. So let's come down from 4. Let's try 1 times 3 plus 2. That would give me 5. 2 times 3 plus 2. 2, 3, 6. 6 plus 2 would be 8. So that can't work. So let's try 1 times 2 plus 3. So 1 times 2 is 2. 2 plus 3 is 5. That works there. 2 times 2 is 4. 4 plus 3 would be 7. So that works. So let's try 3 times 2 plus 3, 3, 2, 6. 6 plus 3 would be 9. So we see that works for all. So 11 times 2 will give me 22. 22 plus 3 would give me 25. So that works there. So now we want to find a number here. So here we can do, we can skip this piece and go to n. So we know the formula to move from n to here would be, so you know it's n times 2 plus 3. So n times 2 will give you 2n plus 3. So that would be the answer. So to find for this number here, we can simply equate this number here to 49. So we can say 2n plus 3 is equal to 49. And when we work this out, we will get the value of n, which will be this number here. So we can simply solve this. So 2n is equal to, so this 3 is added. When we take it to the subtract, so we'll have 49 subtract 3. So we'll have 2n is equal to 49 subtract 3 would give me 46. So n would be equal to, so this 2 is multiplying, we take it over, divide 46 divided by 2. Hence n is equal to 46 divided by 2 would give me 23. So here it would be equal to 23. So we are good there. So now let's see how we can move, how we move from here to here. So let's see, so 5 times 2, that would be 10 plus 2, that would be 12. So let's see, 7 times 2 would be 14 plus 2 would be 16. 9 times 2 plus 2 would be 20. So that works. So that means 25, let's see, 25 times 2 would be 50 plus 2 would be 52. So 49 times 2 plus 2 should give us here. So let's see, 49 times 2 would equal to 98 plus 2 would be 100, of course. So that means for here as well, we can do 2n plus 3 times 2 plus 2. So of course, I'll need to do some working. This will be 2n plus 3. So I multiply that by 2. And then I add 2 to it. So I use the distributive law and distribute throughout. 2n times 2 would give me 4n plus 3 times 2 would give me 6 plus 2. So that will give me 4n. 6 plus 2 is 8. So 4n plus 8. So here it would be 4n plus 8. So now let's move on to the number of squares, which is this one, which I find to be very easy. So for figure 1, we have 1 plus 2, and then we square it, and we have the answer. For figure 2, we have 2 plus 2, and then we square it, and then we have the answer. And for figure 3, we have 3 plus 2, and then we square it, and we have the answer. So for figure 11, we'll have 11 plus 2, and then of course we square that, and we'll get the answer. So 11 plus 2 would be 13, and 30 squared would be 169. And of course, for this figure here, we'll have n plus 2, and of course we square that. We know this will give us, so we need to work this out. So n plus 2 squared would simply be n plus 2 multiplied by n plus 2. And this will give us, we take the n and we multiply by everything in the second bracket. So this will be n multiplied by n plus 2. Then I take the plus 2 and I multiply by everything here again. So plus 2 multiplied by n plus 2. So n times n would be n squared. And n times 2 would be plus 2n. And 2 times n would be plus 2n. And 2 times 2 would of course be plus 4. And this will simplify to be n squared, 2n plus 2n would give me plus 4n plus 4. So this would be, so n plus 2 squared would be equal to n squared plus 4n plus 4. And 3 marks to that. The reason why it goes to 3 marks is because you had to use some amount of algebra to get the answer. So if you work this out, you'll get 2 and 2, 4. 4 plus 3 would be 7. 7 plus the 2 marks here would be 9. Then I have one more question here for 1 mark. So how many white squares are in figure 11? So let's look at figure 11. So we want the number of white squares. So of course, the number of white squares would be the number of squares that remain after we take out the number of colored squares. So for figure 11, we have 169 squares in total. When you have the box, you have 169 squares when you work it out. And then we have the number of colored squares, the shaded squares would be 25. So to get the number of white squares would simply be 169 subtract 25. So 169 subtract 25, that would give us 144 white squares. So all we had to do was subtract the number of total squares that we had, and we take out the number of shaded squares, and of course that will remain. The white squares, the total number of white squares will remain. So with that, this has brought me to the end of this video, and I trust that you have a good understanding of number theory. And remember to practice, practice, and keep practicing. So until then, I'll see you in the next video in which we'll continue our practice. See you then.